Welcome to Brain Vision.
This is chapter 27, problem number 14. We are given the magnetic field to be 0.128 Tesla along z direction, and we are asked to calculate the flux through the surface ABCD. If you look at the figure, you're going to figure out that the normal vector through that surface, of that surface, ABCD, is along negative x direction. So normal vector is along negative x direction, which means your area vector is perpendicular to the magnetic field vector, which means the angle between them is 90 degrees. Then when we put that information in the flux equation, which is B dot A, and the magnitude of B times the magnitude of area and cosine 90, this gives you 0. So the flux through ABCD is 0. So in part B, we were asked to calculate the flux through befc. So for this case, the normal vector is along negative z direction. Which means B is anti-parallel with respect to the area vector, which means the angle between them is going to be 180 degrees. So let's put this information in the flux equation, B times A times cosine 180, which gives you -1. Then we simply have negative of the magnitude of the magnetic field times the area. So the magnetic field is given to us as 0.128, and we have the area, if you look at the figure, to be 0.3 times 0.3. So then we have 1.152 times 10 to the power of -2 Weber here, flux. Now if you go to part C, the flux through aefd, from a little bit of an trigonometry, you can find the angle between the normal vector and the magnetic field vector. So in this case, your cosine theta, you have to find out to be 3/5. So then the flux, again, is B times A times cosine theta, and you found this to be 3/5, which, let's plug in the other values. The magnitude of the magnetic field was 0.128, and now the area is 0.5 by 0.3 in meters, of course. So then times 3/5, you get 1.152 times 10 to the power of -2 Weber for the flux through aefd. So in part D, we are asked to calculate the total flux through all the surfaces that we have. In parts A, B, and C, we calculated the flux through different surfaces that are given, but we didn't calculate the bottom or the top of the figure that is given to us. So you're going to see that the normal vectors are always perpendicular to the magnetic field vector. Therefore, the fluxes are going to be 0. So when you're calculating the total flux, we're basically adding all those 5 individual fluxes through surfaces to each other. As you know, 3 terms are going to come out to be 0, and 2 are, remember, 1 that got in part B was -1.152 times 10 to the power of -2 Webers, and then the answer to part C was positive of the same number, so that when we add them to each other, we're going to get 0. So this is, as a rule of thumb, when you have total flux through any closed surface that actually encloses a volume has to be 0, right? So here we have